Hey, these are notes 2.6, part 2, so day 2. We're working with composite functions, okay? The composition of functions here. So you can be written either way, f of g of x or f of g of x, okay? I kind of prefer this one here, but this is also used as well. Here's a real-life example of it. So say there's a $40 pair of jeans that is 25% off. If you buy them before noon, it is another 10% off on top of that then, okay? So this doesn't mean that it's 35% off, okay? So what is the cost? We're taking 25% off and then an additional 10% off. So not 35, but we'll see here, okay? So if it's $40 and it's 25% off, that means that we are going to pay 75% of the costs. If it's 25% off, we pay 75%. That comes up to be $30. Now, if it's another 10% off, 10% of this, if it's 10% off, we're paying 90%, which would come up to be $27 as the final cost. Okay? Now, which is better, to have this or to have 35% off? Well, if you take $40 times 35%, okay, well, it would be 35% off, which would be 65%. That comes out to be $26, okay, which is much better than doing this and then that, because we're taking in this scenario we're taking 10% off of the 40. Here we're only taking the 10% off of the 30, which makes a difference. Okay, but anyway, the idea of a composition function is you do one and then you do the other. Okay, so for example, f of g of 2. I like writing it f of g of 2 like this. Okay, so what we're going to do to work this out is work from the inside out. So first thing we're going to do is find g of 2. Okay, g of 2, you take your g function and then plug in the 2. So 2 minus 1 is 1. So we have 4 over 1, which is 4. So g of 2 is 4. Now what we have to find is the f of that 4. So we'd plug it in here. So 2 times 4 is 8. 8 minus 1 is 7. Okay? Pause this next one, see what you can do it. We're finding g of f of negative 3. Okay? Pause it, see what you can do, and then come back. Okay, so first we're going to find f of negative 3. So plug negative 3 in here. 2 times negative 3 is negative 6. Minus 1 more is negative 7. And then we have to find the g of that function. So we take that and plug it in here. So negative 7 minus 1 is negative 8. Sorry, 4 over negative 8, which is negative 1/2. So that's the idea of g of f of x and f of g of x. Okay, now, same idea here, but it's a little bit harder because it's an x here instead of the number. But still the same idea. We're finding g of f of x. Okay, so we're going to start out here, just like we took the 2 and plugged it into the g. We're going to take the x and plug it into the f, which it's already there, right? So the f of x is 4x plus 1. And we're finding g of that. Now, to find g of that number, we have to take that and plug it into the g function. So that comes up to be 2 4x plus 1 squared plus 5 times 4x plus 1. So we're just taking that f function, plugging it into the g function here. Okay? So to work this out, I'll do this part on the side. 4x plus 1 times 4x plus 1, right, squared, is 16x squared. And 4x would be 8x, and plus 1. So we have 2 times 16x squared plus 8x plus 1. Okay, and we distribute through. We have 32x squared plus 16x plus 2 plus 20x plus 5. Gives you a total of 32x squared plus 36x plus 7. And that is our answer to g of f of x. Now we're going to do the other way. This is f of g of x. Okay, so the first thing we do is take the x, plug it into the g. So plugging it into the g, it's already there. So we're finding f of our g of x function, which means we're going to take this and plug it into the f function, right? Plug it in there. So it's going to be 4, and we plug it in there. And we have that. Okay, distribute it through. You have your solution. Okay. Okay, so the next one, number 11, we're going to let h of x be this. Okay, and we want to find what are the f of x and the g of x functions, okay, to give us this result. Okay, so you kind of think about this. What is my original function that we start with? So for example, in this one, we're kind of starting with this one here, right? 4x plus 1, and we're taking this and we're plugging it in there, right? So we think here, what's being plugged in? Okay, well, the x squared minus 5 is being plugged in, right? That's my g of x function. Okay, so the g of x function is the x squared minus 5. The f of x function, okay, we're taking that g of x function and we're plugging it into what function? So we're plugging it into here and here. So that would be x to the third minus 4x plus 3. Okay. Pause it and give this one a try again. Okay, same idea here. What is f of g of x? Okay, so what are we taking and what are we plugging it into? Okay, so our g of x function would be this function, 2x plus 3. The f of x function, okay, we're taking that function and plugging it into the cubed root of x minus 4. So you can see you take that g of x function, it's plugging in right there for that x. Okay, some application problems here. So manufacturing costs, you have a fixed cost, something like a factory. You also have variable costs, like how many people you have working and how much time. That's kind of variable. So we have a cost function, which is c of x is equal to our variable cost. So m, how many man hours or whatever, times x, plus the fixed cost, things that don't change. We also have our revenue. Okay, revenue is how much we're bringing in. So the price times how many things we sell would be how much money is coming in, the revenue. So our profit, okay, our profit would be the revenue, how much we're bringing in, minus the cost, how much it's costing us to make it. That's how much profit we're making. So a businesswoman invests $1,500 as her fixed costs to a satellite radio device. Each device costs $100 to manufacture and sells for $125. Okay, so what are the costs here? Well, the costs, c of x, would equal the variable costs. Okay, the variable one, it costs $100 per device, so $100 for every device, plus the fixed cost, which was the $1,500 initially. The revenue coming in, we're selling it for $125 per device. So that's how much money is coming into the company. So the profit is going to be how much the cost is minus how much money we're bringing in. I'm sorry, that's the wrong way. Profit is how much we're bringing in minus how much it's costing me. Okay, so then if I distribute that through, that's a negative 100. So 125x minus 100x is 25x minus 1,500. So we're making $25 per device, and yeah, we have that fixed cost as well. So to make a profit, we need this equation to be greater than or equal to 0. Okay, so we want our profit to be greater than 0 to make a profit. So you solve that, and you get x has to be greater than or equal to 60. Okay, actually, to make a profit, it wouldn't be equal to. It would just be greater than. So if we sell more than 60 devices, we will make a profit. Okay. Next problem. Surface area of a sphere, a ball. Okay. Surface area is the distance around. So if you're going to make a baseball, how much material would you need on the outside of the baseball? Is 4 pi r squared. We're going to construct a model, we'll call it d of r, that describe the amount of surface area gained if the radius increased by 2 inches. Okay, so if we have a certain ball with a certain radius, if we increase that by 2 inches, so we have r plus 2 more inches, how much more surface area would there be on that ball? Okay, so it would be the new ball minus the old ball. This would be how much more there is here, right? So the new ball is 4 pi, the new radius squared, minus the old ball, which would be 4 pi r squared. So if I square this, this would be r plus 2 times r plus 2, which is r squared, plus 2r plus 2r plus 4r, and 2 times 2 is 4. If I multiply this through, 4 pi r squared plus 16 pi r plus 16 minus 4 pi r squared, and you notice those cancel. So we have 16 pi r plus 16. That would be how much more radius there is. So if we start with a radius of, let's say 10, okay, if I take 10 plus 2, it would be 12. So the distance, the surface area of 12 versus 10 would be this amount right there when you plug in the r, the 10 there. Okay, so here's an example then. Determine the amount of extra material needed to manufacture a ball of radius 22 inches compared to 20 inches. Okay, so we can use this right here. So our difference, okay, of how much is going to be used would be 16 pi times r plus 16, using that equation there. And if you multiply this together, 16 times pi times 20 plus 16 more gives you that many square inches. So if it takes that much more material to cover the outside of a ball of 22 inches versus 20 inches.